Hello guys, today is another day. We are going to learn about the pH and the pOH of aqueous solutions. So one may ask, what is pH? pH is a measure of the concentration. Is the negative logarithm of the measure of the concentration of the hydrogen ions present in an aqueous solution, whilst the pOH is the measure of the negative logarithm of the OH ions present in a solution. So these values are used to determine the alkalinity and the acidity of substances. So let's look at the picture there. Now we say pH. So what can you say from this picture? We can say that the pH is the measure of the concentration of the hydrogen ions in the first solution. So let's take the hydrogen ions there. They are 1, 2, 3, 4, 5, 6, 7, 8. So that concentration there will be the pH there. And there's only one OH. Obviously, you can see that this solution is acidic because the hydrogen ions are more there. And let's look at picture B. You can see hydroxide ions 1, 2, 3, 4, 5, and H plus ion only 2. So from this you can say that this solution is basic. Why? Because the OH ions are more than the hydrogen ions. So this one, if you want to find the pOH, you use the negative logarithm of the OH ion concentration there. Thank you. So let's start. The pH of an aqueous solution. The pH is defined as the negative logarithm of the base 10 of an hydrogen ion concentration. What I said earlier, the pH is equal to negative logarithm of the hydrogen ion. pH is defined as the negative logarithm to the base 10 of hydroxide ions. That's pOH is equal to minus logarithm of 10 of hydroxide ions. So these are the formulas used to calculate the pH and the pOH. You have to take note of these formulas. It's needful. We'll be using them in our calculations. Let's continue. The lower the pH or pOH, the higher the hydrogen or hydroxide ion concentration. pKw, that's the power of the ionic product of water, which is equal to the negative logarithm of the Kw, which is equal to 14. And we will know that pH plus pOH is equal to 14. That's the value for that. And the Kw is the ionic product of water, which is represented by the ions that form water. That's H plus and OH minus. So let's go on. So let's try and answer on this question. The question says, calculate the pH of an aqueous solution of 0.003 molar hydrogen ions. So we are given the concentration of hydrogen ions to be 0.003 molar. So that's what I'm writing there. Hydrogen concentration of the hydrogen ions is equal to 0.003 molar. So now, from earlier, the formulas that I say you should take note. We are using one here. You know that pH is equal to the negative logarithm of the OH ion. So substituting the value we were giving into it, pH is equal to the negative logarithm of 0.03 molar. Can't forget the new unit. After that, you finish, you add a unit to it. So now our pH, we add our pH to be 3.25, which makes it acidic. Always take note of the formulas I've given you. Yes, you have to take note of that. because it's needed here. We use it for calculating our pH. Let's continue. Let's look at this question. What is the ion concentration of a solution whose pOH is 11.5? Oh, what a nice question. So we are given the pOH to be 11.5. But we all know that pH plus pOH is equal to 14. So thereby we can find the pH easily. So it's actually 14 minus the pOH, which is 11.5. So when you subtract, our pH is going to be 2.5. That's our pH. And they say for what? Find the hydrogen ion concentration. You know that pH is equal to the negative logarithm of the hydrogen ion concentration. So it's easy to find the hydrogen ion concentration. So that's what I've written there. Now the H plus ion is equal to 10 raised to the power the pH. Antilog of both sides, that's what you get. 10 raised to the power the log. So the answer we had was 3.1 times 10 raised to the power minus 3. That's the answer. But let's look at question 3. Calculate the hydroxide concentration at 25 degrees Celsius in a solution whose pH is 5.78, where ionic product of water is 1.0 times 10 raised to the power minus 14. Remember the formula for ionic product of water. Know that a pH is equal to the negative logarithm of H plus ion. So calculating the concentration of the OH ion. No, calculating the concentration of the hydrogen ion is equal to 10 raised to the power the pH, which is equal to 10 raised to the power 5.78. And our answer we had was 1.6 times 10 raised to the power minus, where Kw, that's the ionic product of water, is the product of the H plus ion and the OH minus ion. That's the ions forming the water. So let's go on. OH minus concentration will be equal to the Kw on the hydrogen ion concentration. So putting the values there, 1.0 times 10 raised to the power minus 14, all on. So how had our answer to be 6.25 times 10 raised to the power 9. That's our answer. Let's move on to another question. Calculate the pH of an aqueous solution of 0.05 mole per dm cube of trioxonitrate 5 acid. You know that this is a strong acid, so it will dissociate completely, leaving no NOH behind. So you can write an equation for that. So this is the equation. NOH maps. So the initial concentration and the final concentration. So the initial concentration was 0.05 molar of, and the final the initial for the ions is 0.0, and the final NaOH becomes 0.0 and the ions become 0.05. So you know that hydrogen ion concentration from what you have written there at the final stage was 0.05 molar. Another name for molar can be mole per dm³, but we prefer to use molar. Okay, so where pH is equal to the negative logarithm of the H plus ions. So we just substitute the value in. We had our pH to be 1.3. We have our pH to be